Hello guys, welcome back to our channel. Today we are going to discuss about what is a master slave JK flip-flop and how what are the benefits of this master slave JK flip-flop. In the JK flip-flop, we have a one drawback when we apply the both inputs as the logic 1. If you observe that if you apply the logic 1 at the J and the K as well as the clock, then here we will face a racing condition in the JK flip-flop. Racing condition means here if we apply 1 in J and the K, the Q and the Q bar will be always toggle with each other. That means 0 1 1 0 1, it will be continuous to each other. That means 0 1, next 1 0 0 1. In this way the logic will change continuously in a single clock cycle. Continuously changes. This is an undesirable state. So to avoid this racing condition, the master slave JK flip-flop is introduced. Let us see the diagram of the master slave JK flip-flop and their clock waveforms, and also the Verilog code for the master slave JK flip-flop. So here this is the master slave JK flip-flop. In this is the master and this is the slave. This is the JK flip-flop, this is the master slave JK flip-flop. There is a difference between the JK and the master slave. Here we have add another circuit and we are taking the Q and the Q bar at the end of the two logic circuits. Okay, here the performance means the master works for the positive clock cycle and the slave works for the negative clock cycle, because we are connecting a inverter, right? If we apply the negative clock cycle, then it will be converted into the 1 and this flip-flop will be worked. Simply we can say that this will be acting as a memory element. And here another thing is, if master is works, slave will not be work, and if slave is work and the master will not be work. In this way the operation will be done. Here nothing but we are increasing the delay, we are increasing the propagation delay so that the racing condition will be allowed. Here why the racing condition is obtained in the JK flip-flop? Because it will be continuously changes, because there is a less propagation delay than the clock cycle. So if we increase the propagation delay, then it can change only one time in a single clock cycle. Let us verify. I will show you in the waveforms. Suppose I will take clock as a high, okay, and I am taking the J as 1 and K is also 1, and we have to obtain Q. Here I am considering here as a QM and here I consider as a QS, because QM is the master, QS is the slave. Okay, QM and the QS, and here I will consider entire J as a logic 1 and K is also a logic 1. Let us verify whether QM and the QS are performing correctly or not. Just I am drawing these lines to can clearly understand. Okay, I am initially assuming that QM is 0. Okay, QM is 0. Now if J is equal to 1, then and clock is also 1, now the QM will be toggled and continues until the negative clock cycle, and the QS is also initially I am considering as a 0, and it will start change of when the negative cycle appears. If the positive cycle 1 means if 1 is applied, then here 0 will be applied, then the circuit will be in the off state. So this will continue until the negative off cycle appears. So here now the 1 is come. Now here 1 is come and we are taking the feedback from this state to the previous state. But if here 1 is obtained, right, and it will be go to this feedback, but here what it is done, here J and here the master flip-flop will not be work, because here applying is the negative off cycle. So in this way the racing condition can be avoided using the master slave JK flip-flop. In this way the master slave JK flip-flop will be used. Simply we are increasing the propagation delay of the circuit so that the racing condition will be avoided in this master slave JK flip flop. Let us see how to make the Verilog code for this master slave JK flip flop. Okay guys, now let's start making the Verilog code for the master slave JK flip flop. So for that I am creating a module called module master slave. Here we will declare some inputs. Inputs are nothing but the J, comma K, comma clock, and the outputs are output register Q and the, and simply it has a QS and the QS bar. Okay, that means slave output and the slave bar output. Okay, and I am declaring wire QM and the QM bar because the master outputs are in between the circuit, right? So in between the circuit we have to mention the outputs as a wire because the final output is nothing but the slave and the slave bar. Okay, right? So I am using the always at the rate POSIX clock. That means it will only work at the POSIX begin. Begin, what are the conditions now? If j equal to 0 and k equal to 0, then what will happen? Qm equal to 0 and qm bar is also equal to 0. Okay? Or I will declare it as a 1. Okay, because both are complement, right? So then else if now if j equal to 0 and the k equal to 1, now what will happen? Now qm equal to 0, and I will use a less than or equal to. This will the syntax will make able to store the values by qm, and qm bar is nothing but the complement to the q, right? Then now else if again if j equal to 1 and k equal to 0 begin. Now what is the value of the qm? Qm will be 1, or simply you can also declare it as a 1b1, or simply you can declare it as a 1. Both will be work out, and qm bar again it will be equal to complement of q. And next finally else in the condition means here if j equal to 1 and the k equal to 1, this is means here the qm will be complement to the q, and that means the previous state qm, and here I forgot to write else begin. Okay, now qm bar will be complement to the qm bar. Okay, so this is for the master. Now we will write for the slave. This is for master. I am just giving as a comment lines master. Now we will write for the slave. Here, right? Here I am again answering right. Now I will write for the slave. So here always a great negative edge. Yes, it will go for the negative edge clock because we are connecting inverter for the slave circuit, right? So I'm writing a negative clock and begin. Here nothing but here QS will be just complement to the complement mean just it will be act like as a QM. It will act like a memory element, right? So QM and the QS bar will be equal to QM bar. Okay, so this is the design code for our master slave JK flip flop. Now where I will write the test bench module DB. Here what are the inputs register J comma K comma clock, and outputs will be wire QS comma QS bar. Okay. Now I am extracting the inputs from the design code. So for that, what will be I do master slave, master slave. Just copy the name what I have put in the design code. I will just paste it. Space one. What are the inputs and the outputs? J comma K comma clock and Q S and QS bar. Right. So these are the inputs and the outputs for our module. Now I will give initial, that means I am giving the test means initial begin, initially clock equal to 1, and I will use the forever command. Forever forever, that means forever, for every 10 seconds the clock will be complement itself. That means it will be changed. If initially the clock is 1, it will be changed to 0 and 1 and so on. In this way it will be changed. So clock, and I'm ending this. And here I will write the commands dump file command so we can see the waveforms the output. So file.pcd dollar dumpers 1. Okay, now I will give the main test bench initial begin. Here initial I will give the j equal to 0 and k equal to 1 and some time delay $10, and I will just copy it. Now I will write, and I will write continually 1. Let us see whether it will work for us, because the major condition we are checking for this is to avoid the raging condition, right? So I think this will be the enough for our module to verify. So I am writing the dollar finish and finally end module. So this is the code, test bench code for our module. Let us verify whether it is working or not. So for that I am selecting a some tool, I open a pwave, and I will start and save this file. Yeah, here I will give the name as master slave JK flip flop, and I will post this code in the GitHub also. This code will be this link will be available in the description. Okay, I'm again saving this file. As in this model, here there is some error in the design.sp.6 here. In this modeling, in the behavioral modeling, we have to use register instead of wire. Okay, now I'm saving this file and I will run this. As you can see here, initially the j equal to 0, k equal to 0. So for that, according to our code, the q is qs equal to 0 and the qs bar equal to 1. Okay, now when the j equal to 1 and the k equal to 1, it will not reset at this because it is a pause edge. In the pause edge, the master will be work and the negative edge clock the slave will be work. So when the slave and the negative edge is obtained, this toggle will be happen. In this way, the master slave flip flop will be work. If you have any doubts, please mention in the comment section. And thank you for watching this video. Stay tuned for the next video.